Chapter 7, Normal Curves and Sampling Distributions, Section 7.2, Standard Units and Areas under the Standard Normal Distribution. Focus points of this section are: given mu and sigma, convert your raw data to z-scores. Given mu and sigma, convert z-scores to raw data. Graph the standard normal distribution and find areas under the standard normal curve. First, z-scores and raw scores. Normal distributions vary from one another in two ways. The mean mu may be located anywhere on the x-axis, and the bell shape may be more or less spread according to the size of the standard deviation sigma. The differences among the normal distributions cause difficulties when we try to compute area under the curve in a specified interval of x values, and hence the probability that a measurement will fall into that interval. It would be a futile task to try to set up a table of areas under the normal curve for each different mu and sigma combination. We need a way to standardize the distributions so that we can use one table of areas for all normal distributions. So I hope this is clear. For different mu and different sigma, you will get different normal curve. But we want to be able to find area, so it's better to have a table for one particular normal distribution. So that is the standard one. We achieve this standardization by considering how many standard deviations a measurement lies from the mean. In this way, we can compare a value in one normal distribution with a value in another different normal distribution. The next situation shows how it's done. So we want to take our normal curve and convert it to a standard one. So we'll see how it's done. For example, suppose Tina and Jack are in two different sections of the same course. Each section is quite large, and the scores in the midterm exams of each section follow a normal distribution. In Tina's section, the mean was 64 and her score was 74. In Jack's section, the mean was 72 and his score was 82. Both Tina and Jack were pleased that their scores were each 10 points above the average of each respective section. However, the fact that each was 10 points above the average does not really tell us how each did with respect to other students in this section. So I hope it's clear the problem, right? In one class, the average or the mean was 64 and Tina received a score of 74, so 10 points above 64. In Jack's section, mean or the average was 72 and he scored 82. So both feel good that they are 10 points above the mean. But that alone is not sufficient to know how they did with respect to other students in the section. So this is Jack's section, 72 and 82 is his score. Tina's 74 was higher than most other scores in her section, while Jack's 82 is only an upper middle score in his section. Tina's score is far better. Well, they have missed to explain to us what the standard deviation is. All right. So here they need to tell you the standard deviation. So basically, if the standard deviation explains the spread of your score. So if the standard deviation is small and you're 10 points above the mean, then you have done much better than the rest of the students, and so on. Okay. So this situation demonstrates that it is not sufficient to know the difference between a measurement and the mean of a distribution. We need also to consider the spread of the curve. What we really want to know is the number of standard deviations between the measurement and mean. The distance takes both mu and sigma into account. So this is what we want. Difference between measurement and mean divided by standard deviation. So x minus mu over sigma. All right. The z value or z score gives the number of standard deviations between the original measurement x and the mean mu. So z value basically measures how many standard deviations you are away from the mean. Mean is mu, x is your raw score, sigma is your standard deviation. So this fraction tells you how many standard deviations you are away from the mean mu. All right. The mean is a special value of a distribution. What happens when x is mu? If I plug in x equals mu, I get mu minus mu, 0 over sigma. Any 0 over anything non-zero will be answer is 0. Okay. So the mean of the original distribution is always 0 in standard units. This makes sense because the mean is 0 standard variations from itself. An x value in the original distribution that is above the mean mu has a corresponding z value that's positive. So if x is mean mu, then standard deviation is 0. If x is bigger than mu, then number of standard deviations is positive. Z score is positive. Greater than 0 means positive. If x is less than mu, then standard score is less than 0. Okay. We will continue the next slide in our next video.